Winter 2015, question 11, QP11. The diagram shows part of the curve y equals bracket 1 plus 4x bracket close all to the power half and a point P 65 lying on the curve. The curve PQ intersects the x-axis at Q 80. Show that PQ is a normal to the curve. Okay, so question 11, question 11 QP11, as was read to you, it's still bringing us back to the idea of the application for tangents. Remember again that when you have a curve, okay, when you have a curve, the gradient of a curve at a particular point is the same as the gradient of the tangent at that point on the curve, okay? And the tangent is also perpendicular to the normal and vice versa. So therefore, when you know the gradient of the normal, the negative reciprocal gives you that of the tangent. When you know that of the tangent, its negative reciprocal will be that of the normal. You are fine. So problems of this nature, as you've seen in the examples repeatedly, always have got to do with the three. What is the gradient of the line at the point? Its effect on the gradient of the tangent, and also if that is the tangent, what is the gradient of the normal? Okay, so let's just delve into the problem as we were shown there in the diagram that was shown. Okay, so the curve shows part of the curve, and we are saying that the part of the curve is y. Just a bit of the details. Part of the curve is y equals to 1 plus 4x all to the power 1 over 3, right? 1 over 2, yes. Let's correct that. 1 over 2. Okay. And we are saying that there's a point P 65 lying on the curve. Okay, so the point P, and the point P has got the values of 65. I'm sure you saw the diagram. That was what was said. The point P has got 65 lying on the curve. Now we are saying that the line PQ intersects the x-axis at Q0. So we're given the point Q, and Q is what? 80. So the line PQ intersects the x-axis at that. All right. So the question says that we should show, okay, we show that PQ is a normal to the curve. We should show that PQ is a normal to the curve. Okay, so what do we do? Now, for us to show that PQ is a normal to the curve, we should be able to find the gradient of the curve at P, all right? Then find its negative reciprocal. If the negative reciprocal is the same as the gradient that we'll get for the line PQ, then we can say that it is a normal. Hope you're okay. Let's take it again. The relation between the gradient of the normal and that of the curve at the point is that the gradient of the curve at a particular point should be the negative reciprocal of the gradient of the normal. So if the question is asking us to find whether PQ is the normal, then what it means is that the gradient of PQ, its negative reciprocal, should be the same as the gradient of the curve at the point P, because that is where the line meets it, if you look at the diagram. Are we okay? So first, let's try and see if we can find the gradient of the curve. Now, y is equal to 1 plus 4x all to the power half, as we know. So we'll try to find dy dx. Okay, so what is dy dx? We try to differentiate that. That's going to give us half, okay, into bracket 1 plus 4x, okay, half minus 1 is minus half, okay, times 4. Hope you're okay. All right, of course, we differentiate what is in there. So when we try to resolve that, this is going to give us 2 all over the root of 1 plus 4x. Hope you're okay with that. Okay, so this is dy dx, 2 over 1 plus 4x. So what is the gradient of the curve at point P? What's the gradient of the curve at point P? Okay, so let's try and do that. Okay, so at P, which is 65, okay, our dy dx is going to take the values when we slot x in there. So when you put x equal to 6 in here, 6 times 4 is going to give you 24, plus 1, that's going to give you 5, okay, that's going to give you 5, then the root of 4 times 6 is going to give you 24 plus 1, that is 25. The square root of 5, the square root of 25 is 5. But remember, when you look at the nature of the slope, okay, if you look at the way the curve slopes, or the slope to that, you should know what that should mean, okay? It has kind of a negative situation, but this is just the curve. All right, so divide the x of that. What do we get? Okay, so when we put that in, we are going to get divide the x equal to 2 over 5, all right? Because the square root of 25 is that, so this is going to give you 2 over 5. All right, so now what we are saying is that this is the gradient of the curve at point P. Now I want to show that the normal PQ, like PQ is the normal to the curve. So what is the gradient of PQ? Okay, so let's look at grad PQ. Okay, so we know for the gradient of PQ is very simple. It's a straight line. And for straight lines, what do we do? Y2 minus Y1 all over X2 minus X1. That is the gradient of a straight line. So when we take them as it is, with the corresponding values, X1, Y1, X2, Y2, what happens? We are going to have 0 minus 5, which is minus 5. Then 8 minus 6 is going to give you what? 2. Guys, are we okay? 0 minus 5 is minus 5. 8 minus 6 is 2. So the gradient of the line PQ is equal to minus 5 over 2. Now, this is the final part where we can conclude. Is PQ the normal? If it is a normal, it should be the negative reciprocal of the curve. So now let's look at the gradient of the curve, which is 2 over 5. If we were to take the gradient of the curve, divide the x, and turn it upside down and put a negative, would you get minus 5 over 2? Let's just see. It is obvious. So when you have 2 over 5, you turn it upside down. What do you get? You get 5 over 2, then you take a negative. So clearly, the negative reciprocal of the gradient of the curve, divide the x, gives you the gradient of the line PQ. Hence, we can confidently say that PQ is a normal to the curve. So that is the conclusion of that. Okay? PQ is a normal to the curve. In other ways too, you can also take the product of the curve and that of the normal. If it gives you negative 1, you still have that proof. So you can even just check that. 2 over 5 times minus 5 over 2. What do you get, guys? So it's obvious. The 2's will cancel. The 5's will cancel. This is going to give you negative 1. Okay, so the product of the curve, the gradient of the curve, and that of PQ gives you negative 1. Hence, PQ is the normal to the curve. Question 9, QP13, winter 2015. A curve passes through the point A, 4, 6, and is such that dy dx is equal to 1 plus 2x to the power negative half. A point P is moving along the curve in such a way that the x-coordinate of P is increasing at a constant rate of 3 units per minute. I. The tangent to the curve at A crosses the x-axis at B, and the normal to the curve at A crosses the x-axis at C. Find the area of triangle ABC. Okay, so let's look at question 9 of QP13, 2015. As was shown, we'll just try and get some of the key parts again. So we have a curve that passes through the point A, and A was given to be 4, 6, right? Okay, so the point A is said to be 4, 6. And we are saying that it is such that the dy dx, that is the gradient of the curve, okay, is 1 plus 2x to the power minus 1 over 2. Okay, and we are saying that a point P is moving along the curve in such a way that the x-coordinate of P is increasing at a constant rate of 3 units per second. The II part of which we are interested in this particular section of the video, the tangent to the curve A crosses the x-axis at B. Okay, so the tangent to the curve at A cross the x-axis at B, and the normal to the curve at A cross the x-axis at C. We want to find the area of the triangle ABC. Are we making sense of that? I'm sure it's very simple. So we are saying that the tangent that goes through the point A, okay, the tangent that goes to the tangent to the curve at A crosses the x-axis at B, and the normal to the curve at A crosses the x-axis at C. So we want to find the area of that. So essentially, we need to find the coordinates of B and C. When we know the coordinates of B and C, we can find the area of the triangle that's in question. All right, so let's see what happens. So this is what we know. This is the point A, that is Y. We are speaking about a tangent. What do? We want to find the tangent or the equation of a tangent, which is a straight line. You need to use the 1-point formula. Y minus Y1 is equal to M into brackets X minus X1, which means that the gradient needs to be known and 1 point. Here we have a 1 point, we have an expression for the gradient. So what do? We just do a direct substitution there. All right, so at A, what is going to be the gradient? So at A, we can say that our dy dx is going to give us 1 plus 2 into bracket 4 raised to the power minus half. Okay? So what happens to that? What happens to that? Now, if you deal with that, we should have our gradient to be, our gradient of the tangent to be 2. Okay, so now we can find the equation of the tangent at point A. So equation of the tangent, using the y minus y1 equal to m into brackets x minus x1. Bear in mind that we are using point A. You're going to have y minus 6 is equal to 2 into brackets x minus 4. All right? Okay, so what happens? Our tangent is going to give us y equals to 2x minus 2. So this is the tangent of the curve at point A. Now, we are being told in the problem, remember, they are saying that the tangent to the curve A crosses the x-axis at B. The tangent to the curve A, which is y is equal to 2x minus 2, crosses the x-axis at B. So what do we do? So on the x-axis, we know what happens on the x-axis. Y is equal to 0. Guys, hope you understand that. On the x-axis, y is going to give us 0. So let's take this expression, which is the tangent. That is the equation of the line that is going to the x-axis. So we have 0 is equal to 2x minus 2. So from this, we can find that our x equal to 1. Hence, point B has got the coordinates of 1 and 0. Are we making sense of that? Are we making sense of that? All right, so that is what we are saying, that point B is going to give you 1 over 0, because the problem says that point B is that point where the tangent will cross the x-axis. And this is the equation of the tangent that we found. And hence, when we look at the equation of the tangent and try to find where it crosses the x-axis, it does so at point 1, 0, and that is B. Okay, so the other portion also says that the normal to this tangent at A also crosses, okay, also crosses the x-axis at C. So we also need to find the equation of the normal. But remember, the equation of a normal is always perpendicular to that. Now, the gradient of the normal is the negative reciprocal of the gradient of the tangent. So if at point A, we know the gradient of the tangent to be 2, then the negative reciprocal of that, which gives us the gradient of the normal, so grad n is going to give us negative 1 over 2. Hope you are fine. Guys, hope you're okay. All right, so that's what we know. What is the equation of the normal then at point A, where we know this is the gradient? Okay, so the same, y minus y1, so we see y minus 6 is equal to m minus half into brackets x minus 4. Okay, so when we do justice to this, we should have our 2y, okay, plus x being equal to 16. And we are saying that this equation of the normal also cuts the x-axis. So at x-axis, what happens? We have c. So we say at c, which is the x-axis, y is also equal to 0. So we're going to have x equal to 6. Okay? So the coordinates of c is going to give us what? 6 and 0, guys. Any problem? So point A is 4, 6. Point B is 1, 0. Point C is 6, 0. So what do we do? What do we do? We need to find the area of the triangle ABC. So for the area of the triangle, what do? We use a shoestring method. The shoestring method. At this juncture, if you are wondering what the shoestring method is, you can just please visit our website at www.learnwestafrica.com and just take the course on the revision courses on coordinate geometry, how to find the area of shapes. Like in coordinate geometry. The shoestring method is discussed there, and it's extensively discussed, so you can do that, okay, on our website. Okay, so just going by the shoestring method, the area of the triangle ABC, okay, area of triangle ABC, what are we going to get? So we're going to have half, okay, so ABC, so we have 4, 6, 1, 0, 16, 0, then we have another 4, 6. So when you do the computations on that, the area of your triangle should be 45 square units, okay? All right, so you can either use any other appropriate method, but like I said, if you want more information on the shoestring method, please remember to visit our website and watch the revision video on coordinate geometry, how to find the area of the triangles and quadrilaterals, problems of this nature, and you have an extensive explanation of what the shoestring method is. But if you have any other appropriate method, which is also discussed still in that revision course, please do not hesitate to just go and take it. In any case, the area of the triangle ABC that we are looking for is going to be 45 square units, and that is the end to question 9, QP13 in winter 2015.